Um, Hi guys. So I want to quickly, summarize those courses in Atlas. Okay. So if you are very familiar with that course, you discover that the first thing there was function. Okay. So we didn't go straight to Atlas. It was function. Okay. I know you can hear some noise in my background. Okay. So I want to quickly touch that function before I go straight to calculus, okay? And I'm going to post it direct. So we have function, okay? Alright. So what is function? I want to bring function to your own understanding, okay? Now look at function. Function is something you can create on your own, okay? So let's assume I have a system of of business. Alright, let's say I'm a banker now, okay? I'm a banker. Anytime you give me money, alright, if you give me 1 naira, hmm, I'm going to multiply that 1 naira times 2 plus 4 naira. If you give me 2 naira, I'm going to multiply that 2 naira times 2 plus another 4 naira. Do you understand me? So what that means is that anytime you give me any money you give me, let it be called S. So first of all, you give me 1 naira, then another person give me 2 naira, or let's say another person give me 4 naira again. So let's just take in all these values, okay? So what is the system of my banking? The system of my banking system is that if you give me if you give me any money at all, I'm going to multiply it by 2 and add 4 naira to it. Okay? I'll multiply it by 2 and add what? 4 naira. So now this is the system of my banking. So the system of my banking is a function. So let's try and do what we said we are going to do. So I said if you give me 1 naira, I'll multiply it by 2, right? And add 4 naira to it. So you are giving me 1 naira now. Hmm? So it means that I'll multiply that 1 naira by 2 and add 4 to it. So 2 times 1, that is 2 plus 4. At the end of the day, your money with me is now what? Is now what? 2 plus 4, that's what? 6 naira. Do you understand now? So you can now calculate for another person. So let's say another person now give me 2 naira. So remember, this is the system of my banking. Okay? So another person now give me 2 naira. Eh? So what will you result? If you put 2 naira here, just like I put 1 naira here, what is it going to give me? That's 2 times 2 plus 4. Eh? So 2 times 2, that's what? 4 plus 4. What will you give me? 8 naira. Now, when you take in all this value, let's take the next one. F of 4. F of 4 will give us what? That will be what? 2 times 4 plus 4. So now 2 times 4 will give me what? 8 plus another 4. That will be what? That will be what? 12 again. The last one, F of 5. F of 5. So 2 times 5, if you give me 5 naira, I multiply by 2 and I add 4 naira. So 2 times 5 is 10 plus 4, that's 14 naira. Do you understand now? That's the meaning of function, okay? Function has a receiving end and an output, okay? So if you give me, I'll do an operation to it, then it will not give you a result. Okay, that's the meaning of function. Can you see? This is function. This is function. Do you understand me now? So everything we have done here now, look at what is the result now. The result that this is my input, what I'm going to put in. So I put 1 naira, and I put 2 naira, and I put 4, and I put 5. So it will now give me 1 naira gives me what? 1 naira will give me what? I hope you have seen the board. I hope it's clear. Eh? So 1 naira gives me what? 1 naira gives me what? 6. Can you see? 1 naira gives me 6. 2 naira gives me what? 2 naira gives me what? 8. 4 naira gives me what? 4 naira gives me what? 12. And 5 naira gives me what? 5 naira gives me what? 14. So this is called function, okay? So what's the function? The function is what? F. This S, don't be confused about this S. It's just a way of typing it. Let's type it. Let's make it, let's give it a variable, okay? This F at the end of the day will be Y, okay? And the Y is just a way of typing it. Let's call it the name of the bank, okay? If I put 1 letter into Echo Bank, if I have F of S, that should be Echo Bank. If I have H of S, that should be Diamond Bank. If I have D of S, that should be like UBA. You understand? It's just name of bank. It's a variable. All of them are just Y because we are relating S and Y. You know, when we have a Cartesian plane, you have S and Y plane. So the Y plane is all these functions you are getting. I hope you understand now. So now, after I've drawn this map like this now, this one that is your input is called domain, represented with letter D. Are you see that? Domain is represented with letter D. Domain. Okay? Letter D. I hope you can see, okay? Domain. Okay? Alright? So let me move my camera a bit. That one. So, this is domain, letter D. Now, that's all the number here. So, because it's a set of number, we call it set. Okay? It's a set of number. It's a set of number, so we call it set. I hope you understand. It's a set of number, so it's a set. I don't know if you get. Right? So remember, it's a set of what? Number. Let us take it like so. I don't know if you can see the word this. Okay? So it's a set of number. We call it set. What is a set of number? It's a set of value. And we have different type of set of numbers. Okay? Set of real numbers. Most times we use real numbers. The meaning of real numbers are all the numbers. They are coming from negative numbers. You have minus 5, minus 10, minus, you know, uncountable. So that's we take minus infinity. You understand? Minus infinity. Then you have positive numbers as well. So that's what? Positive infinity. So real numbers is coming from minus whatever to infinity. Positive infinity. So let's say from minus million to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You understand? So it's a set of numbers, okay? So our domain, the elements there are all set of numbers. So it now gives us another set of numbers, okay? So each set of numbers that is our answer or the result or our output or what the bank will give you at the end of the day. Those set of numbers are now called codomain. Alright, codomain. I hope you can see the board. Don't mind this matter. So all this set is what? Codomain. Are you getting me now? Good. So the values that we get from operating these ones, all these numbers that we slot in and get this one, those values that we get, this value that we get, we call it range. We call it what? Range. Are you getting me now? We call it what? Range. I hope you understand now. Good. So now, since we now understand function, let's discuss some other things, okay? Before we discuss other things, I want you to test whether you understand this in any way. Function can be any form. That one I discussed earlier is what we call linear function. Why is it a linear function? All I need to do is multiply and add or subtract. Anything I do, multiply, add, or subtract. So I have other function. The function could be exponent. Let me try an exponent function so that you see. So let's see d of s. Let's use d of s. I hope the board is clear. Good. Let's use d of s. So we have the function of d of s. And d of s is s raised to power 2. That is an exponent function. Can you see that? So what that means that this bank, whether it's central government bank or whatever, this bank now, if I give them 3 naira, it will be like this, 3 naira raised to power 2. So what it means is that anything that is in this place that S is occupying is what you put inside S. So if I put 3 here, I'll still put power 2. You understand? That's mathematics for you. So once you understand this, you are good to go. So what will I get at the end of this? That will be what? 3 raised by 2. That's 3 times 3. So 3 times 3 will give me what? 9. That is exponent function. And this is exponential. The value is exponential. I hope you understand now. So there are many kinds of functions, okay? So I'm going to discuss other things later. Now, what I'm trying to do is I want to make sure I follow our elements, okay? So the question is, what is not a function? What is not a function? Look at this outside element now. Now watch. You see that 10 produce 2, and 10 produce 4, okay? 3 produce 10, and 5 produce 7. 7 produce 7, 7 produce 5. You see that some of the elements in this set have they have multiple outputs. So as long as they have multiple outputs, their answer is not the same. Like you put 5 naira, you are getting 1 naira. You still put 5 naira, and you are getting another value like 7 naira. It's no longer a function. Okay, so this is not a function. I hope you understand. If a particular element in this domain is giving more than one output, it's no longer a function. I hope you understand that. So now, the question is, what is a real valued function? I have 2 functions here now. What is a real valued function? A real valued function is the one that what we call it, codomain. Remember, this is codomain. The output will be a real number. Okay? The output will be what? A real number. You can see this one we have a real number. 1 gives you 2, 7 gives you 1, 8 gives you minus 1. We have a real value, so that is a real valued function. Okay? But in this case, you can see a letter here, K. A gives you K, and B gives you 2, C gives you 3, D gives you. So this is not a real valued function. Non-real, what? Real valued function. I hope you get that. Non-real valued function. I hope you understand that. So what is that? So very quickly, we need to understand the graph of some function, okay? So I'm going to explain the graph of 2 functions, okay? Or maybe 3. Now, if we have a linear function, and the meaning of linear function is that the s does not have any power. So if I have a function of s now, and it's like, let's say 3s minus 5. This s does not have any power. That is a linear function. The s will not have any power, either power 2, power 3, or power 4. You understand me now? Good. So, for every linear function, it's going to be a straight line. Every linear function will be a straight line. If you plot it on a Cartesian plane. So, and what is a Cartesian plane? When you have a graph, your graph will be s and y, right? Good. So, when you plot the graph, either it goes like this or like this. It's going to be a straight line. It's going to be a straight line, okay? Are you getting me now? And whatever you have here will be the slope. Whatever you have in front of that s, the coefficient of s will be the slope of that graph. Please, you can see that question. What is the slope? Just pick whatever you have in front of s, alright? Alright. So now, let's look at this. A quadratic graph. When you have a quadratic graph, the highest power of a quadratic equation or function is 2. So let's have h of s, and s is having a power of 2. Let's say s raised by 2 plus something, or just s raised by 2. This is still a quadratic graph. Or let's just say s raised by 2 minus 4. This is still a quadratic graph, okay? So every quadratic graph, we have a positive quadratic graph and a negative quadratic graph. Take note. A positive quadratic graph will go like this. By the time you start finding the value of s, you put the value of s1, you can start from 1, 2, 3, 4, 5. You can start putting 1, 2, 3, 4, 5. And you get your output. Whatever output is here is your y. And whatever value you put inside is your x. Are you getting me? Remember, that's your range. This is range. Range is always like this. Good. So when you plot the graph, it's going to go like this. That is for positive. Then when it comes down like this, that is for negative. Do you understand me? Right? Okay, so now, The next thing is that what to discuss how to find the domain. Alright, so let me start with this one. No. I want to start with a more simpler one. So let me use the examples in the LMS. So now I want you to look at my board very well. These questions are directly from the LMS, okay? So you have find the domain of a function. Look at the function s squared plus 3s plus 2. The next one, what is the domain of f of s, 3s plus 1, s squared plus 5? Domain again. So what the meaning of domain? Domain is, remember, if we have this, what do you call it? If we have our function like this, okay. I hope this thing is clear. If we have our function like this, domain is what? The number will slot in here to give us a result. I hope you remember. The number will slot in here to give us a result. The number is slot in here to give us a result. So domain. Now, do you know that if I have a very fixed function, if I have a fixed function, like this is a fixed function, this is a fixed function, or if I have a function, there are some numbers you can put in some numbers that when I operate it, my answer will be 0. You know, when I operate it, I'll get 0. So whenever they ask you to find the domain, it means make sure you consider that is there any number that you're going to put inside the function to get 0? Is there any number that when you put it inside the function at the end of the day you're going to get 0? Do you understand me now? Good. So look at the first number now. Look at the first question. Now look at the first function here. F of s squared plus 3s plus 2. What are the numbers that we can put inside this function now? That is, when we say we put the value of s now, and the whole result will give us 0. Is there any number? There's practically no number, because any number that we put now, even if I put 0 here now, if I put 0 for s, if I say f of 0, this one will end up in 0. This my marker is just, I don't know. This one too will end up being 0. If I put 0 here, this one will end up being 0. Now 0 raised by 2 is 0. 3 times 0 is 0. I will still get 2. Any value I put inside here, I will still get something reasonable. I will still get 2. Last I will get 2. So there is no number that I am going to put inside this function now, and I will get 0 at the end of the day. You understand me? So that means that our domain, that is all the set that can enter our domain. Remember, the set that can enter our domain are those numbers that when you put, you must get the result. Anyone that you put, you get 0 must not be part of your domain. That is the whole idea of all this finding your domain. You understand? So, since there is no number I'm going to put for this question, since there is no number I'm going to put inside for me to get 0, it means that my domain starts from negative infinity. There's no number at all. From negative infinity, all the negative number, 1 million, 3 million, all the negative number minus 1, to positive infinity, 1 million, 2 million, positive infinity. Do you understand me? So negative infinity to positive infinity are all those numbers are all part of my set, because if I put any number at all, I'm not going to get 0. Do you understand that? Okay, now look at the next one. Okay, what is the domain of this? So now this one, whenever you want to do for a fraction, once you see a fraction, that one is very easy. For fraction, all you need is that the denominator must not be 0. Do you understand that? That denominator, look at the denominator. What is the denominator here? The denominator here is s squared plus 5. So whenever you have a fraction, it's very simple. The denominator must not be 0. That is, s squared plus 5 must not be 0. Can you see that now? So s squared plus 5 must not be 0. If you still solve it, you are going to see that s squared plus 5 minus 5. So if s squared is not equal to minus 5, simply, if I put any value I put for square, if I put minus 1 for square, minus 1 times minus 1, that will give me plus 1. If I put minus 2 for square, minus 2 times minus 2, that will give me plus 4. If I put negative number, I'm going to get, you understand it? If I put negative number, I'm going to get positive. I don't know if you understand. So, all the negative numbers that I might put inside S now, I'm going to get positive. If I put positive numbers here, I'm still going to get positive. So actually, if you look at it very well, if I put negative number, I'm still going to get a positive number. If I put s raised to power minus 2, s raised to power minus 2 times minus 2, that will be plus 4. So if I put negative number, I'm still going to get positive number. If I put positive number, I'm still going to get positive number. That means actually, the negative number will not really make this one 0. Let me show you what I mean. If there is no square here, I'll put minus 5 here. I say s minus 5. So minus 5 plus 5. You are having 5 naira and you are owing 5 naira. That's 0. You understand? So if there is no square here, if I put minus 5, I will end up having 0. And remember, our denominator must not be 0, because if you divide this whole number now, divide by 0. If I divide this whole number, divide by 0, the answer will be 0. And remember, we must not have 0 as our output. We must not have 0 as our output. So we are avoiding it. So we are looking for, we are in search of any number that when we put, we get 0. Or any set of numbers. Is there any number or set of numbers that when we put? In the next example, you understand. So the domain in this one is also a set of what? It's also a set of what? All negative number and positive numbers. You understand? We're going to see another example now. Now, listen. Look at this one. So we are looking for, what is the question again? So we are looking for the domain in this, right? What's that question again? We are looking for the domain. Now look at this one. Now, in this case, if we are looking for the domain, what would be the domain? Remember, the domain is, we are trying to avoid any number that when you put it inside S, you will end up having a non-real number, right? Or 0. I get me now. So in this case, listen, in this case, whenever you have a root, when I put any number here, it must not be minus. I must not operate. Let me give you an example so that you understand. So if I have, let's say root, and let's say my s is minus 5. If my s is minus 5, I have put s as minus 5 here. So you have minus 5 plus 2. What is the result? You have the result, minus 5 plus 2 is minus 10. You are owing 5 naira, you have 2 naira. If you pay 2 naira, you are still owing 3 naira, that's minus 3, right? Now look at this. This is a complex number and it's not a real number. It is complex, kind of complex. Let me say complex or imaginary number. Please take note. So it's not a real number. So it's not under this set. Remember, our function is a set of real numbers. Like the set of R. Look at the set of R, real numbers. So anything we are dealing with real numbers. And they will stick in there. Okay? So the values that we will put inside here, that must make sure that this is not 0 and it's not minus 3. What will happen? At the end of the day, you discover that whenever you have a root, the best way to answer this question is just say, okay, this, whatever operation I have inside this root must not be, or must be greater than 0. It must be greater than 0 because from 0 you now have 1, 2, 3 positive numbers, so it must not be negative. So whenever we are saying it must not be negative, it has to be greater than 0, right? So S is greater than minus 2. So all the numbers minus 5. You can see minus 5. When you put minus 5 then you have minus 3. If you put minus 4, you have minus 2. If you put minus 3, you have minus 1. If you now put minus 2, you will now have 0. Can you see? I will not want 0. Can you see now? We don't want 0 for our portion. So if you stop at minus 2, anytime I put minus 2, I will now have 0. So what's the next number? Minus 1. If I put minus 1, I will now have 1. If I put minus 2, I will now have, you understand? You get it now? So you stop at 2. That's what I see here. You stop at minus 2. Can you see that now? So what will be your set? Your domain will now be a set of starting from, can you see? You can see the grades now. Look at what I'm putting now. Starting from what? Minus 2 till all the positive numbers. From minus No, not minus 2 because minus 2 will give you 0. So it's 1. So you start from minus 1 in all the positive number. I know that somebody already understands this. So I'll do one more example, okay? So in this case, look at this question. Find the range of f of s to s. Now this one, you're not looking for domain. You're looking for range. And remember, range is the output you will get at the other side, right? So you're looking for range. So if you want to find range, what you do is you try to find the inverse of the function, okay? So inverse of the function is the simplest thing you can do. Okay, I hope you are following me now. So what is the inverse of this function? This function, remember I told you that is y. Whether it's f of s is y, right? So y is equal to 2s minus 9. So we are trying to make sure that whatever is inside the other side will be y, not s. That's the minimum. So let's try and make it. So for you to do that, you have to make this s subject to the formula. So you see the way y is on one side, then s is on the other side. Yes, that is inverse of function. So you're going to make sure that this s is at this side, then y is at the other side. That's the meaning of inverse. So let's try it. So we have y plus 9 equal to 2s. That is when you move this line to the other side, right? Good. Then you divide both sides by 2. Why is dividing both sides by 2? So that this 2 can cancel this 2. So at the end of the day, you now have your s equal to y plus 9 all over 2. Can you see that now? So this is inverse of function. And because it's a function, you know what to do now. You don't need to leave y here. You have to return it back to s because it's a function. So you just say y. This one take it to y. That is, you just reverse it. When you reverse it, then you take the letter. So this y return it to s. This s return it to y. So that's plus 9 over what? Over 2. So you reverse it, then you now find the domain of this reverse. So the domain of this reverse is now the range. You understand? If you do not reverse it, if you do your, like this one now, let's say we do not reverse it, this one now, what is the number that will put, that will not produce 0, that will produce 0, and you understand? So there's no number that will put here now that will produce 0. Even if I put minus 1, minus 2, I'm still going to get answer, like minus 5, minus 3. The answer can never be 0. So for this one, the domain is what? Actually from negative to what? Positive infinity. Please take note of my the sign I'm using. Alright? So, but for this one now, that's we are already reversing, so we are not looking for the range, no more domain. If you reverse it, you are not looking for the range. But if you do not reverse it, you are looking for domain. So now, if we are reversing it now, inverse function, what number are we going to put here? What number are we going to put? I hope we got this thing correctly. Right? Yes. But I want to make sure that my question is correct. So I'll say it, my question is correct. So remember, first of all, you reverse it. So when you want to reverse, just turn this whole thing to y. I'll set it again. So y equal to 2s minus 9. Then you are making this transformation from the formula. This 9 will come here. That's y plus 9 equal to 2s. Are you getting it now? Divide both sides by 2 so that this one will stand alone. So 2 to this 2 will cancel this one. So it means that s, this one now, this s now is now what? Y plus 9 over 2. So what's the number that will make this one there? There's no number. There's no number. If I put minus 5, minus 2, I'm still going to get the value. Any number I put here now, I'm still going to get the value. It's something you can try. If I put 1, any number you put here, you're still going to get the value. Non-zero answer. So the range is also from what? Infinity to what? Negative infinity to what? Positive infinity. So because I want to stop here, now let me just quickly do. So what of if I have a situation where I'm looking for y equal to 2s plus 1 over s. You know, when you have s here, any number you put here now, any number you put here, apart from 0, can you see? If you put 0 here, that's where you're going to have problem. If you put 0 here, any number you put here, you're going to get the value. So, what do you say at this stage now? I don't know if you understand what I'm saying. So, let's just summarize this thing because you know today is Sunday and I'm ministering in my church today. So, what? Let me just quickly do this. So, let me just do this. I hope Because after this now, we're going straight to calculus. I need like to do this record it so that everybody that will be part of my calculus class must have gone through this. Calculus will be very easy. I don't know, but we need at least like 2 hours. Alright, 2 hours. So we might do that later today. Okay? But look at this very well. Now, if you want to solve it, this one is the easiest. You know what I say this one is the easiest? In this question, I think they say we should find the range. Alright? They say we should find the range. Now, if you are looking for the range in this one, so what will be the range is that anytime you have an absolute number like this, absolute number will be positive or negative. That means it is plus or minus, okay? Positive or negative, okay? So if it is positive, it will be greater than 0. If it is positive, this you know. Then if it is negative, it's going to be what? Less than or equal to 0. I get it. So any value at all that is absolute, this absolute value will give us. Any value at all that it will give us. At the end of the day, if you want to put this 2, if you put this 2 to both sides, this 2 that is here minus 2, you add 2 to both sides. So if I add this 2, I will end up having what? 2 minus absolute value of what? A x minus a, right? Are you getting me? Greater than or equal to what? Let's add 2 to both sides. This y, let's make it 2. So if y is 2, whatever number you put here, this is what you, I'm adding 2 to both sides because remember this one can give us positive or negative number. At the end of the day, the range, you know we're looking for range, you know you have to reverse. So this one you don't need to reverse, just look for it straight. What will be the result, the output? At the end of the day, you discover that it's only 2 that can be able to cancel this 2. Are you see? Only 2. By the time you bring this one here, this 2 minus 2 is 0. So it's only 2 that will cancel that. That will make it uncertain. Because this one we are already certain that we make positive or negative number. So at all, we just know that from 2 upward we make this one 0. Are you getting me? So at the end of the day, the result will be what? Negative numbers will not have any effect. But 2, right? 2. So it's starting from negative number to 2. Every other number is going to give us our business. So now I'm going to help us to go through our calculus. So make sure you go through this video properly before you enter the calculus class. Thank you.